All right, we are now recording. Go back to PowerPoint. Okay, I thought we had already done all this, but I guess we'll do it again. Okay. Oops. Okay. Finally, let's get the slideshow set up. Wow. Front slide. And it goes back to this. Sorry about this. Third time today. We'll hide presenter view and do this, and this time I think we're okay. Fine. All right. Now, we already did this slide, so don't sweat this one. Any questions on anything we've done up till now? Okay? If not, finally, we'll get started today. And since it doesn't give me a screen to work from, let me just make sure it doesn't. I don't think it gives me a blank screen down here. It does not, as far as I can see. So I'm going to operate on this screen. Okay. I think we're finally ready to go. Example 4. Factor this. X squared plus 7x plus 16. Okay? How would you begin?
Try to see what numbers go up. Make that 16.
Okay.
Also, you do it with a bracket.
Okay. Yeah, draw your brackets. Assume, since this is a trinomial, that it hopefully will factor into two binomials. So that's what those represent, the binomials. And as you said, let's start with the x squared. Only possible factorization for that is x times x. Very good. Then where do we look next? The sign of the last term. And that is what? Plus, which means these two signs have to be, not necessarily, they have to be the same, but in this case, yes, because the middle sign is plus, they are both pluses. But just the fact that it's a plus on the last means that those two signs have to be the same. Now we need two numbers that multiply to be 16 but add to be 7. Ain't that going to happen? Not in, you got 1 and 16, that won't work, obviously. 2 and 8, that won't work, obviously. 4 and 4, that won't work. So guess what? This is not factorable. So we call this a relatively prime problem. Not factorable using integers.
Looking at that problem, you say, look at x squared, then you got plus, and plus sign, if you look at it, pretty much tell that most times it's not factorable, right?
Yeah, but look carefully. Okay. Yeah.
That's what I'm saying. So when you look,
Right.
what exactly do you look for? The x squared?
No, just the fact that there's x squared, that's usually a good sign, x and x. And that there's both pluses, that's not a problem, plus and plus. But that there's no way you can factor 16 to give you 7. Now, here's what I look for, and this is just because I'm used to doing it. 16, the only factors for 16 is 2 times 2 times 2 times 2. So guess what? All those factors are going to be even, right? And can you add two even numbers together and get an odd? No, you can't. That's what I look at. But I'm used to doing this. But that's what when I look at that, I say, no way to look at the very beginning. But it's only because two even numbers can't. Now, not just because this is even. 14 would be even, but that has an odd factor, 2 times 7. Okay, I'm not saying that would work here. But 16 has no odd factors. No way you can add even factors together and get an odd number. So this is not factorable. Okay. And for some reason, my pen has decided, there we go, to write 3 times, okay. Now, I hate sort of that this is an option here, because I can done this many years. You may see on a quiz or a test something to factor that can't be factored. So not factorable is a legitimate answer. Okay. But what it means is it is not factorable by anybody. Don't think that just because you can't factor, you say not factorable and that's going to count as true. No, it has to be truly a non-factorable. Not that you would do that, okay? So you can't just write them all down as not factorable. You probably aren't going to do too well on that one. All right, let's do another besides the point. Here's one. Factor this. N squared minus n minus 72. Whoa, okay? Where would you start? Okay, you hope that it's factorable by two binomials. It's a trinomial, okay? Where do we begin? Okay, n squared is going to be either n or n. And where do we look next? Sign of the last term is negative. That means these are plus and minus, okay? Now we're looking for two numbers that multiply to be 72, but differ by only one. 9 and 8, right off the, now, it doesn't matter where we put the 9 and where we put the 8. Why? Okay, so you want, since the negative wins here, you want the bigger of those two factors, 9, to go with the minus sign there. Okay, so we do 9 here times 8 here. And guess what I always do, or I try to do always? Check it. Okay, let's do our FOIL. N by n, n squared, negative 9n, plus 8n is negative n, and then minus 72. Perfect. Now, the reason I say that, if you had guessed wrong and put the signs in the wrong place, when you checked it, you would have the wrong sign for this. If you have the wrong sign, just change signs. Now, if you wind up with the wrong number there, change your numbers. And there are other numbers you can use. But if you have the wrong number, change numbers. Wrong sign, change signs. I've never seen a book write that, but to me, that's a pretty good thing to use. All right, one more. Example 6, factor this one. T squared plus 2t minus 168. Are you kidding me? Okay. All right, where do we begin? Okay, yeah, you hope it's going to be factorable by two binomials. And obviously the first has got to be a t times t. Where do we look next? Sign of the last term. What is it? What does that tell you? Opposite. One's going to be plus and one's minus. It doesn't matter where you put them. Now we want two numbers that multiply to be 168, but add, or actually the difference between them, because they're different signs, is only 2. 14 and 12. Y'all are good. I'm looking at the book. Okay. Which is going to have which is going to go with what sign? Yeah, because it's bigger and this sign wins. The plus wins in between. So this will be 14 and this will be 12. Now, in case you were doing that, not that I would dare say you were, but when you have big numbers like this, this is just another hint. I've never seen a book tell you this, but a hint. And small numbers here. Of course, for that to happen, these have got to be opposite signs, so that better be negative. Here's my little trick, okay? For these numbers to be real small, that means these two have to be pretty close together, right? Obviously, okay? Now, so what I do, cheating as it is I look at this and say, well, what's the square root of 72? I don't know what it is, but what's the square root closest to 72? A perfect square closest to 72. 64. And what's the square root of 64? 8. So I'm going to guess the smaller number is 8, and the next one's a little bit bigger. 9. Ha. How will that work here? what's a perfect square close to 168? 144, which is the square root. The square root of that is 12. So let's try a 12 and a 14 because the difference has to be 2 here. See, I cheat, okay? And it's okay for you to cheat that way, okay? When it's mathematically doing. Okay. Okay, what did you kick? Oh, yeah, my eraser. That's my valuable eraser you just kicked on the floor. Okay. All right. It's, I know I called your name, and I'm not finding it now. I'm in the bright light, and I cannot see. Just tell me so I can get it. Huh?
Justin.
Justin, yeah, I know, but what's your last name?
Jordan.
Second? Jordan. Okay, there it is. I see it now. Okay, good deal. Okay. Unfortunately, they put it alphabetically by the last name, not the first. Okay, now let's check this one and see if y'all were right reading the book. No, okay. T times T. T squared. Minus 12T. Plus 14T. Sure enough, it's plus 2T. And then I guess that's negative 168. Okay, good deal. All right, any questions on that? Okay, now, if it's a big number here and these numbers are closer together, I mean a bigger number here, and that's a negative sign, then you're probably going to have to start doing what the book does and try different combinations of your multiples there. We'll see that coming up next. You can always go back and use them here. The book's been talking about that all along. You can certainly do that. Okay. Now we're going to move to a whole new field. Okay? And that's factoring trinomials of the form ax squared plus bx plus c. What's different with this what we've been doing? Yes, you have a coefficient for that squared term. When that was an x squared, guess what? The first answer was always the same, x times x, right? Okay, now we don't have that because now it's preceded by a coefficient, okay? And that's going to throw a lot of your little tricks off a little bit, so we'll get to what to do here. Okay, we have been factoring trinomials of the form x squared plus bx plus c. That is trinomials where the coefficient of the squared term is 1. Those are nice. I hope you enjoyed them, okay? Because you're not going to see that many. You'll see some. Okay, now let's consider factoring trinomials where the coefficient of the squared term is not 1. First, let's illustrate an informal trial and error technique, and frankly, that to me is the way to go on most of these. That works quite well for certain types of trinomials. Now notice it's trial and error. Expect to get these wrong on your first try sometime, okay? Keep testing, checking, make sure you get it right. This technique is based on our knowledge of multiplication of binomials, which of course we've already done. We usually do that by foiling, right? So let me come down here and erase the ink because I was using this slide. Okay. They didn't show you much, they just dumped you right into it. So let's do. We start really a lot like we did before. What is our first assumption? That, yeah, we put our parentheses there because we hope this is going to be, if you're going to factor, it's going to be a factor to 2 binomials. We ask the same question. What's the only factorization of 2x squared? 2x times x. This one was pretty easy because that's the only thing you got there. Okay? And the next question's still the same. That's why I use this technique. Where do we go next? Sign of the last term, and that's plus. And what does that tell you about these two signs? They've got to be the same, and since that's plus, these have got to be plus. Okay. Plus and plus. All right. Now this one also is fairly easy. What's the only possible factorization for 5? 1 and 5. Okay. You want to write it in that order? Boy, y'all are either good or lucky or looking in the book. Okay. Not that you would do that. Okay. Let's check it. 2x times x is 2x squared. 10x plus, sure enough, is 11x plus 5. Y'all are really good, huh? Okay. Now, if you had written this 5 and 1 and done your FOILing, you would have gotten the wrong number here. And what do you do if you get the wrong number? Change numbers. Exactly. If you had the wrong sign, you couldn't have the wrong sign here if you did everything else right. You change signs. If you have the right number but wrong sign, change signs. Right? Well, it doesn't matter about the sign. If you have the wrong number, change your numbers. Try something else. This one was pretty good because there's only one factorization here, only one factorization there. All of it depended on what order you put the factors. That's it. Okay? So that one was pretty good. Okay? Well, let's see. I think I'll probably have to erase this. So let me do that. All right. And by looking at the first term, just like we did, 2x squared, and the positive signs of the other two terms, so they did them both at once. That means one of these is x and one's 2x. Doesn't matter which order you write it, plus and plus. They threw that all in together. And then they're going to see how to get the last two terms. Because the factors of the last two terms, 5, or 1 and 5, we have only two possibilities. They wrote them both down, okay? And then what you do is FOIL it and see if it works. This one would be 2x squared. That's fine. 5x. That would add to 7x. Wrong answer. Don't use that one. Use this one. But check it like we did. 2x squared plus x plus 10x. That's 11x. Yay. Plus 5. Yes. So that one works. That's why they call it trial and error. Try the factorization. Test it. If it works, go with it. If it doesn't work, try something else. The trial and error part. By checking the middle term formed by each of those products, we find that the second possibility yields the correct middle term, 11x. Therefore, that's your factorization. Okay? We're writing it down as many times as possible. Okay, now, before we get to another method, we'll go back and do, that was example 7. Let's do example 8. Okay? All right. Here's example 8. 10x squared minus 17x plus 3. Now, what's just a little bit different about this one? Okay, 17's a big number in there. I agree with that. But where do we begin? Factoring the 10x squared, and that's where we run into our difference. What's that? All right, there are actually 4 different factorizations, really 2 for this. Before, there was only 1 or 2. Now we got multiples. It could be 1 and 10, or it could be 2 and 5. So you got more things to choose from. Okay? Now, the good news is 3 only has 1 possible factorization there. So you can either do trial and error, or this other method that we're going to get to in just a minute, we'll do that one. Okay? You want to try first, or do you want me to go to that new method? Okay? What you want? What's your first guess? What's the factorization for 10x squared? 2x and 5x? Is that what I heard? Okay, we'll write that down. 2x and 5x. Okay? And then where do we look next? Okay, and what is it? And what does that mean? Okay, and what is it? Negative. Both got to be negative. Because that's a positive, these have to be the same. That one's negative, so they both have to be negative. And then what's the only factorization for 3? For 3? 3 and 1. We'll put it in that order and see how we go. Okay? Test it. 10x squared, that's fine. Minus 2x. Okay, who's looking? Okay, y'all are so good. Okay, or so lucky, or something. You got it right first time again. Y'all don't have any errors. Y'all only do trials, huh? Okay. So 10x squared minus 2x minus 15x, that's minus 17x plus 3. Y'all are too good, okay? All right. Let's see. Can you continue this? Let's try this one. 4x squared plus 6x plus 9. Okay? Where do you go from here? Okay, and what is the only possible? Well, there's several possible factorizations. Which one you want to try first? 2x times 2x. Not a bad place to go. Next. Look at the signs. What is it? Plus. What does that tell you about these two signs? Have to be the same, and they both have to be plus. Okay? And then where do we look? Yeah, okay, and what's the possible factorization there? 3 and 3. Okay? And what happens here? Okay. Boil it. What do you get? 4x squared. That works so far. Plus 6x. Plus 6x. That's going to be plus 12x. Not going to work. You want to try another factorization. Okay? Here's another little hint. When you have chosen the smallest numbers you can, the other possibility would be 1 and 4. That's going to give you a bigger cross product. Okay? Now, it wouldn't necessarily if they were opposite signs, but when they're all pluses, that will give you a bigger thing because, 4 and 1 is 5. That's bigger than 2 and 2 is 4. And same thing here. The only other possible factorization here would be 1 and 9. Well, 3 and 3 is 6, and 1 and 9 is 10. So guess what? Those are only going to give you bigger numbers. There's no way you're going to get that. Okay. Now I'm going to jump way ahead now and give you another hint. Okay? When you have something like this that you suspect of being, because these are pretty good sized numbers, and you're going to be adding because they're the same signs, that's a fairly small number. Then you can check, and this is jumping way ahead, but do any of you remember what they call the discriminant? Okay? It's when you're doing the quadratic factor, the quadratic formula. You remember how that goes? A few of you do. Let me just tell you now, we'll get to it later. That is going to be, the discriminant is b squared minus 4ac. Okay? It's a weird thing to remember, but you can write it down. Remember, all your tests up until the final exam, you can have written down anything you want to. So let me tell you that b squared minus 4ac. Now, what in the world do you think that a, b, and c is? Did I just make that up, pull it out of my ear or some other part of my anatomy? No. Please say no. Okay, now, where did that come from? Remember what we called this form? ax squared plus bx plus c. That's my a, b, and c. So what's my b here? 6, and b squared would be 36. Minus 4 times, what's my a? 4, and what's my c? 9. Okay? Now, this is really cheating to take you this far ahead. But let me just point something out to you. Notice what this is? 36 right here, right? Times 4 is going to be a big number, a lot more than 36. You're going to have 36 minus a bit number bigger than 36. What's that going to give you? A negative number. If this discriminant ever turns out negative, now you can write down, guess what? Not factorable. Okay? That's one thing that your discriminant tells you. It's a discriminator. It can answer a lot of questions for you. Here's another thing it can do. If that number turned out positive, but not a perfect square, not factorable, okay? So those are two things you can look at with your discriminant. Number one, if it turns out negative, stop right there. Not factorable at all in the real number system. But even if it turns out positive, but the difference between those two numbers, or that could be a plus, because remember, this sign or that sign could be plus or negative, So keep up with your signs, but if that turns out to be not a perfect square, then it's not going to be factorable also. So just a couple little hints, that one's not factorable. You can try all the other combinations in the world, it's not going to work. Okay? All right, not factorable. And they did. In the book, they show you all the different possibilities. None of them work. Okay. So that may lead to another, this is that example 7 we've already done. Another method for factoring of the form ax squared plus bx plus c. And here's when I use this. When a has more than one possible factorization and c has more than one factorization, or when the numbers are just really big and ungainly, then I'll try this other method. It takes maybe a few more steps. So trial and error you can usually do in 2 or 3 steps, right? If y'all are as good as you are, you don't ever make an error. But most of the time we do. So you might try 2 or 3 different things. But if you got 5 or 6 or 7 to try, this method will save you some time. Okay? Now the way the book presents it, when I read it, I go blah, blah, blah. Okay. By now it's obvious that factoring trinomials of this form can be tedious. Okay? The key idea is to organize your work so you consider all the possibilities, especially when they do that table and stuff. We suggested one possible format in the previous example. As you practice such problems, you may come across a format of your own. Okay? In fact, maybe your 098 instructor, your high school teacher, maybe they told you some technique. If it works, use it. Okay? There was an adjunct instructor here, Miss Mary Stringfellow, a fantastic math teacher, and she had something called the scissor method. And she just loved it, and her students loved it, but I never found out what it was. She retired, and I never found out what her scissor method was. But whatever works best for you is the right approach. So there's another more systematic technique that you may wish to use with some trinomials. And here's what that is now. Again, this part I go, if that's the best you can do. To see the basis of this technique, let's look for the following product. This makes it clearer, doesn't it? Okay, px plus r times qx plus s. When you follow that, you get px times qx, which is pq times x squared. Then you get a psx plus a rqx plus rs. Okay, sure, that's flowing. We understand that. And that's a pqx squared, that's this one. And then these only have one x in it, so it's ps plus rq times x, and then r times s. Okay? Note that the product of the coefficient of the x term and the constant term, okay, is PQRS. Okay, fine. Likewise, the product of the two coefficients of x, PS and RQ, is also, if you multiply these together, which you don't do, is also PQRS. Okay? Therefore, when we're factoring the trinomial, this, the two coefficients of x must have a sum and a product that produce the same thing. Okay? And boy, by putting all these letters in it, that makes it, to me, more complicated. Okay? So I'm going to try to simplify this a little bit. Now, I think we could do this in trial and error. But here's what I call, and other books I've used call this the AC method. Whoops. Okay. Now, again, you tell me what A and C are. Say again? Okay. A is 6 and C is negative 10. Keep the sign with it. So AC, which means the product of those two is, and that's their PQRS. Why do that? AC is negative 60. Okay. Now here's the key. And this is what they were saying, but their words just made it so complicated. What we want are two numbers that multiply to be negative 60, but add to be minus 11. That's what we're looking for. Okay? Two factors of negative 60 that multiply to be negative 60. That's what means by factor, but they add to be negative 11. Now, time out just a moment here. We look at this AC. It's a negative 60. What does that tell you about the two factors? The signs of the two factors. Say again? They're different. One's positive and one negative. Okay? So one of these is going to be a plus and one's going to be a minus. These are the two numbers we're multiplying together. Now, which of these is going to be the larger number? The plus or the minus? The minus, because that B over here is going to be negative 11. Right? Okay? Now, so that means that the larger of these two numbers is going to be the negative. Okay? So I'm going to start with and I'm going to do this in a really dumb way to begin with, just to show you the technique. I'm going to start with the smallest possible first number to multiply by the second number, which has to be the minus number. What's the smallest number that will go into to go into 60? 1, okay? So that'll be 1 times a negative 60. That multiplies to be minus 60, right? What does that add to? Negative 59. Is that negative 11? Scratch that, okay? Okay, next. 2 times negative 30. What does that add to? Negative 28. Guess what? We're closer, but we still aren't there. Scratch that one. What's the next largest number that'll go into 60? 3 times negative 20. And those add to? Negative 17. We're getting closer, folks, but we're not there yet. Scratch that one. Okay? What's the next? 4. 4 times what? Negative 15. What does that add to? Negative 11. Bing, 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 bing. You won, okay? All right. Now what do you do with that? This is where this technique takes on a little bit of a different turn. What you do, you split this negative 11 into plus 4 times negative 15. So you change this to be 6x squared plus 4x minus 15x minus 10. Now, time out just a minute. Isn't this the same as that? 4 minus 15 is minus 11, right? Okay, so that's what you use these for. That doesn't produce a factorization yet, but it gets you on the way. That's how you use that. Now, what can you do with a problem like that? Factor by grouping. Very good. We're going to group the first two terms together and the next two together. Now, that's not a factorization. That's just grouping. In the first group, what do we notice? Both of them have an x in them, but what else? A 2. And what's left if we factor out the 2x? 3x plus 2. Excellent. Now, the second group, what do we notice? Negative 5. And when you factor out a negative 5, what do you have left? Say again? 3x plus 2. Okay. Watch your signs. That's the dangerous thing here. Be sure, remember, when you factor out the minus, you factor out the minus out of both of those terms, leaving you a plus. Now what do you notice? Common factor of 3x plus 2. Factor that out, and what do you have left? 2x minus 5. Guess what, folks? That should be your answer. What do we do? 3x times 2x? 6x squared. Fantastic. 3x times minus 5? Minus 15x? Plus 4x is minus 15 plus 4. Negative 11x, and then minus 10. You got it. Okay? So, again, when this has several factors, this has several factors, you could use, and this is what I call it, the AC method. It's the same method the book's talking about, but they throw in all these PQRSs and stuff like that. To me, that's more confusing than it's helpful. Is this simple enough? Remember that when you find that magic product that gives you the right sum, that doesn't give you factorization, that just gives you a way to split that middle term. Split the middle term, factor by grouping, and then you're home free. Right? Okay. Any questions on that? Let's see how they do it. Basically, wind up doing it very close to the same way. But it doesn't always look that way, okay? Step 1, multiply the coefficients of the x squared term, 6, and the constant term, minus 10. Yes, A times C. Okay, they don't ever call it that, but that to me is much easier to remember, okay? But if you don't like it that way, just do it for x squared terms as the constant term. That gives you negative 60. Now, you find two integers whose sum is negative 11, but whose product is negative 60. And it says it would be helpful to make a listing of all the factors, pairs for 60. Now, I think it's even better to start with saying the bigger of these two numbers, factors, absolute value-wise, needs to be your minus. So therefore, you put the minus signs in there because otherwise, it's just easier in my book. And you start adding those. Don't just write them all down. Add them as you go. When you get the right answer, stop. You don't have to do the rest of them. Stop. So they did 1 and negative 60, 2 and negative 30. They don't work. 3 and negative 20, that's negative 17. 4 and negative 15, negative 11. Stop right there. Why mess with 5 and 12 and 6 and 10? They're not going to help you any. If you did your work as you went, guess what? I'm lazy, okay? I try to skip as many steps as possible. You don't have to. You can write them all down if you want to. Perfectly fine to do it this way, okay? Because the product from the step 1 is negative 60, we want the pair of fractions for which the absolute value of the difference is 11, okay? And that would be the 4 and 15. Now, what we do is for the sum to be negative 11, the product negative 60, now you put in the signs. To me, it's much easier to start with the signs. Plus 4, negative 15, that sure enough works and become negative 11. And the product is negative 60. So, rewrite the original problem and express the middle term, the same thing we did, as the sum of the two terms using those factors. Okay? So that 6x squared minus 11x minus 10 becomes 6x squared plus 4, or actually they did it the other way. Oh, they're going to get a different answer, aren't they? Minus 15x plus 4x minus 10. Uh-oh, they did it a different way than us. Is that going to work? Let's try it. Group. What do you get here? What do we do next? 3 what? 3x, and what do you have left? 2x minus 5. And over here, factor out a 2, and what do you have left? 2x minus 5. And what does that give you? 2x minus 5 times 3x plus 2. Guess what? It gives you the same answer, just in a different order. So it doesn't matter how you write those down. There's nothing special about it. Find the right AC and B. Find the right combination. It doesn't matter how you write it down. You should get the right answer. Okay? So, good deal. You could have written plus 4x minus 15x. Fine. Okay? Any questions on it? Let me erase this so we can see what else they write. Okay? Next thing to do now, use the factoring by grouping. And they didn't put the parentheses. I like to do that, group and group, you know. And in fact, we did the same thing and got the same answer they did. 2x minus 5 times 3x plus 2. Do it the other way, you get 3x plus 2 times 2x minus 5. Same answer. Right? All right. And therefore, your original problem factors is 2x minus 5 times 3x plus 2. Multiply it, check it. Yep, it works. All right, that was example 10. Okay. They skip 11. Let us do 11. Oops, one too many. Okay, let's do 11. 4x squared minus 29x plus 30. Okay, can we factor that? What method you might want to try? Say again? The one we just did, AC method? I like it, yeah. You could do trial and error, just stand by. And the trouble with trial and error on a big problem like this, you might miss one trial. You might miss seeing something. This way, it almost makes it so it's hard to miss seeing anything. So how do we start? Okay, AC, which is 4 times 30, which is 120, being positive. Okay? Now, so it's going to have two factors that we want to multiply to be 120, but we want to add to be negative 29. What does that tell you about these two factors? If they multiply to be 120, they've got to have the same sign. But if they add to be negative 29, that means they have to both be negative. Minus and minus. So go on and write that down to begin with, okay? Minus, minus. Now, again, let's start with the smallest, okay? What's the smallest number that'll go into 120? 1 times 120, okay? Obviously, that adds to be negative 121. Way off. Next, negative 2 times negative 60. That adds to be negative 62. Closer, but still not there. Next one, negative 3 times negative 40. What does that add to? Negative 43. Again, closer, but no cigars. Okay? Next, negative 4 times negative what? 30. That adds to negative 34. Hey, that's getting closer, but still not there. Next one. He was wanting to get there, wasn't he? Okay, times negative what? 24. Okay. What does that add to? That's it. Negative 29. Ding, 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 ding. Winner, winner. What do we do with it? Okay, how? 4x squared minus 5x minus 24x minus plus 30. You're right. I'm writing down the wrong thing. Okay. Now, let's just pause a minute. Make sure this adds to that. Yes, it does. We're fine. Okay. Now what? Group. Group. Okay. Now that is a minus there. My group almost covered that up. What do we do on the first term? Factor out an x, and what does that leave you with? 4x minus 5. And in the second group? Second? 6, but pull out the minus sign. Negative 6 times 4x minus 5. Fantastic. Remember your sign. When you factor out the minus, that changes the sign of both of those terms. This becomes plus. That becomes minus. You're absolutely right. And what do we have here? 4x minus 5 is a common factor. Binomial factor, but fine. Times x minus 6, and then we can check it by flowing. 4x times x, sure enough, is 4x squared. Minus 24x, minus 5x, sure enough, it's minus 29x, plus 30, yes, we did it. Now, the key here is to make sure you don't skip a factor. If you had been jumping ahead and went from minus 6 to minus 4 to minus 6, you'd have missed minus 5. So be careful and get them all. Now, if you had kept going and hadn't gotten the right answer, 7 will not work. You can skip that, okay, but get all the ones that will work. They've given you numbers that have lots of factors, okay, but 7 will not go into that. 6 would have, 8 I think will, but you see, you can keep going for a while, but after a while, and here's the key. Notice, and I already said this, if you do it this way, very systematic, then you'll notice the number is getting smaller here till you get here. Now, if you got to the next one, this one didn't work, or got to this one, and it went to minus 28 or minus 27, you missed it. Guess what you can write? Not factorable, because you did. You don't keep going until you flip them over, and then they start getting bigger again. If you miss it coming down and you hit all your numbers, and it's not there, it's not factorable. Okay, good deal. But make sure you do your math right. Okay, that was example 11. Let's see what they got. 4x minus 5 times x minus 6. Good for them. They got it right. Okay. Now these are, we've already done this, so I'm going to skip on through that. And that. And that. Okay. I think we did that one. Yeah. This is still example 10. All right. Now we get to the next topic. Factoring perfect square trinomials. What in the world do we mean by perfect square trinomial? Of a binomial. That you take a binomial. Give me a binomial. Make up a binomial. Any binomial. Say again? X squared. Is that what you said? Okay. How about just x plus 2? Okay, we could do the other one, but I'm going to keep it simpler. Now, if I'm going to square that, what do I get? What do we mean by squaring? X plus 2 times x plus 2. And when you square those, what do you get? X squared plus 4x, excellent, plus 4. Fantastic. Okay? Now, this is what we call a perfect square trinomial, because it is a trinomial, 3 terms, and it comes from squaring a binomial, a perfect square trinomial. So let's look at some characteristics of that. Number 1, the first coefficient is always a perfect square. Number 2, the last number is always a perfect square. And that sign is always positive. Okay. Now, how about the number in between? Is there anything we can say about that? How did we get it? 2x plus 2x, right? So let's see, we added the middle term twice. So what if we took half of this? That would give us 2x. So that's where the 2 comes from, okay? Because half of this is 2x, but when you square the 2, you get the 4. That's how you determine perfect square trinomial, okay? So number 1, first coefficient has to be a perfect square. Last coefficient has to be a perfect square with a plus sign. That's a minus. It's not a perfect square, okay? Even if it's minus 16, that's not a perfect square because nothing multiplies by itself to give you minus 16, only plus 16. Okay, so it has to be a plus perfect square. And then this term, half of this squared has to give you that. Well, that's not quite true because you may have a coefficient here. But that at least gets you moving in the right direction. All right, let's see how they do it. Before we summarize our work with factoring techniques, let's look at two more special factoring patterns. Okay? We've used the following two patterns to square binomials. A plus b squared is a squared plus 2ab plus b squared. Now, do y'all remember how we did that? Square the first, twice the product, square the last. That's the easy way to do it. If you don't want to do that, you can always FOIL it. But guess what? If you FOIL it, you get a plus b times a plus b. A times a is a squared plus ab plus ab, double, twice ab, twice the product of those two, and then b squared. Okay? Even if that's a minus sign, a minus b times a minus b, a times a is a squared, then minus, let me write it down because I know waving a finger won't work too well. A minus b times a minus b, okay? A times a is a squared, minus ab, and another minus ab. Just like here's my brother Darrell, my other brother Darrell, okay? It's the same thing. So it's minus 2ab plus b squared. Notice a minus times a minus is always plus b squared. So again, this one has to be a perfect square, that has to be a perfect square, and this one has to be twice the product of the square root of those two numbers. Okay? Even with a minus, either minus or plus. These two patterns can also be used for factoring purposes. So anytime you have first term is a perfect square, the last term is positive and a perfect square, and the middle term is twice the square root of those two, you got a perfect square trinomial. Okay? So that'll be a plus b squared. If that's a plus sign, it'll be perfect square here, perfect square there. This is twice the product of those two with a minus sign. That's going to be a minus in there. Those trinomials on the left are called perfect square trinomials, and on the right, they're a result of squaring a binomial. So how are we doing on time? Huh? 1 minute? Just 1 minute? Okay, let's see if we can get one more slide in there. We can always factor perfect square trinomials using the techniques for factoring trinomials. You can do trial and error. You can do the AC method. All those work. However, if you see this, and you see that's a perfect square, that's a perfect square, what's the square root of this? 2x. What's the square root of that? 3. 2x times 3 is? 6x, double that, 12x, perfect square trinomial, write down the answer. So again, first term's perfect square, last term's a perfect square with a plus sign, middle term twice the product of the two, then you know you got a perfect square trinomial. All right. We're not going to have time, obviously, to finish, so let's see, where did we leave off? We're going to do this one right here. That's where we'll pick up next time. Let me give you a few homework exercises. I had hoped we'd finish this section today. We came also close. So do any of the odds 1 through 29. Do any of the odds 31 through 55. Do any of the odds 57 to 61. Do any of the odds 63 through, try any of them 63 through 111. That basically is all of them. But if you do run into perfect square trinomials you can't do, hang off. We'll do those next time. Okay? So get started on that. It's a lot. And next time we will finish this section, and I'll give you your quiz for this first test. Okay? And we're also going to do a little bit on 3.7 because that's some more really good things to work on. Good deal. We will see you Wednesday.